Hello, everyone, and welcome to another episode of Fox Forum. Today, I have the great honour of being joined by Christian Blanchett. Chris has nearly 3 decades of experience across public, private, and government industry roles, including time at JSOC, the White House Communications Agency, Navy Special Warfare Development Group, the Navy Staff, and executive positions within the Department of War. Chris also currently serves as Everfox's Director of Solutions Architects, leading the innovations group and shaping the transformational technologies behind our products. Few people have operated quite so close to the edge of data-driven operations, making Chris our perfect guide as we dive into how data has become the new ammunition across multi-domain environments, namely Golden Dome. Chris, welcome. How are you doing today?
Great. Thank you for the intro.
So I want to get us started with a bit of framing around Golden Dome itself. So when people hear about Golden Dome, they often think of something closer to Iron Dome. Well, I definitely thought that way. How would you best describe what Golden Dome actually is in practice?
I think that the best way to describe Golden Dome is to put it in the context of probably the greatest infrastructure investment from the United States in this new century. If you take what has to actually be built to take all these systems that are out there that live in silos and in air gap networks or disconnected completely from any real scalable use, Golden Dome has to exist first to create a real architecture, to create a new communications pathway for us to be able to operate on in this next century where terrestrial is the limitation factor now.
So in my mind, I'm still thinking of missile interceptors in space. Is that what we're looking at here, or is that part of it?
Absolutely. I think that missiles already exist and interceptors are already a thing. So take all the radars and all these ability to see and shoot already exists. What we need now is to do it at a scale that is far greater than just a regional conflict, a geographical theater, but something that is global in scale. And to do that, you have to have an extremely robust ability to move information around, right, through that architecture, but you have to put it in place. And this is all these layers of this cake end up becoming what Golden Dome is, but it isn't one singular slice. It isn't an effector. It isn't a radar. It isn't a C2 node. It isn't just space transport and space data centers. It is the combination of all that mixology of technology into one thread called Golden Dome.
So, some of which already exists and some of which we're building into the future,
and some which are we're coming up with crazy ideas to solve crazy physics problems.
And you mentioned it's global. Is it over just the Golden Dome just over America or the United States, or is it over parts of Europe? Is it connecting all those different systems around the world, or?
It is connecting all those pieces and parts. You can take just in our strategic missile defense perspective, Romania and South Korea play an important part in that space, same as Alaska. So imagine those 3 places have a strategic imperative to affect a potential strike on the United States. They're all 3 geographically dispersed. They all have to be able to react to the same originating threat location, but at a different pathway. And 3 different geographical combat commanders, NORTHCOM, INDOPACOM, right? And now you have EUCOM. And now you have 3 geographical commanders, all of them having to action one action from one regional actor. That in and of itself is already a complex series of steps and evolutions that we take to just counter that threat today. But to do it at the speed and at the scale that is going to be required, you can imagine that, early on, we would fire maybe 100 missiles, right? Iran has shown that thousands upon thousands of missiles will be coming out of one place, right? Yeah. And in many different directions, and it takes a bigger level of coordination across a geographical area, requiring communications limited by physics to travel in another direction to get to the destination at the speed that is required for us to be able to do that job. And that is like one of the action items that walk through the full use of Golden Dome, right? that is using the systems and the architecture and the communications path and all that robustness and the C2 elements that are staged through to be able to give you that. But that all those layers have to be built out. But the transportation layer, the ability to move that information right across that system in a more modern method is really what Golden Dome is going to provide. Not just us, but just like everything that spins out of the military. The internet is a byproduct of the need for military communications, right? Yeah, personal computers are that transition to that exact technology. So as we look at Golden Dome, we're looking at a new modern way to become a more modern communication infrastructure as a globe, right? This is space is the new thing where putting them there is far easier than trying to drag a cable across the ocean.
Yeah, of course. So we talk about we tend to like sort of focus on like sensors and interceptors within Golden Dome, but is the reality now that the data itself is the thing that is driving the advantage?
That's right. So we've lived in this just like the internet. It was built to be a stovepipe between very specific places, right? So the information would travel there, and once it got there, we would sort it out and figure out where it was supposed to go within that delivery point. What we found is that doesn't work when quick decisions between machine to machine have to be made, or when humans have to make a decision with information in a very quick time sequence. For us, that the time to live and the data density of moving that data, not letting it get all the way to a major communications hub spoke node before that information was looked at, understood, or enriched, and then forwarded back out to the people who had to use it. Any of that delay, milliseconds, hundreds of milliseconds, seconds of delay, right, in a legacy warfare form wasn't going to put you at risk, right? Because both parties were operating under the same communications barriers. But now that we've come to this point where communication is able to be, the density of information is able to be pushed further and further to the edge, the need for people to be able to see, decide, and act at a pace faster than our enemy's abilities to get within that loop is what we call data, right? So what we describe it as moving the data at the speed of relevance. I need to be data aware, understand of at least where that data is allowed to be, and put that data in those areas as fast as possible without having to have human intervention be present to make that happen. So the desire is to move it on the wire, right? If I can close the loop where I don't have to go up to a satellite, down to a ground station, through a terrestrial cable, to a major office building to do what I have to do to then process it and then send it back. If I can get it to happen in space, if I can get it to happen on the wire, then I can start to move data and make people in multi-domain operations aware in a way that today is very stovepipe. It's arcane. It's back to a hub, it's into another spoke, and back out to another hub, right? And all that is a delay, and all that is consumption of bandwidth. That in a modern battle space where data density has gotten so dense, everything's a sensor right nowadays. With that being the case, the consumption of that bandwidth in ways that are not useful to the mission, right, directly useful to the mission, are going to be things that have to be modified in those architectures. And this is part of the whole process of Golden Dome, is working through that complexity.
So it's removing the hub and spoke process and just going kind of making the decision closer to the edge is essentially what you're saying.
That's right. So you want being informed of something happening and taking action used to live in the same exact space. What we're moving to is an AI, ML, human in the loop, right, kind of environment where the decision is now made by somebody of a lesser rank and structure because that decision has to be made at a quicker speed, right? And they're being supported through these robust communications architectures to enable it to be there, but if it's not there, that the mission continues to press on because that data loop from them to the others is still in existence.
So it's also about understanding what data matters and where it needs to go, correct?
That is 100% the important part. Like multi-domain operations have to exist. Everybody has a security level that they organically trust. So the United States has theirs, Britain has theirs, the French have theirs. That's will always and forever be the case, and that's a good thing. But we won't, but we still have to be able to work together in a meaningful way to be able to fight a war that we're going to fight together inevitably. And in that is this need to be able to move, right? Inevitably, we're going to play together. And in that is this need to do it at a very efficient and effective way, while keeping in mind that everybody has a different level of security and risk associated with who they are. For us, that is where the speed of relevance really lives, right? Mission partner environments is the hard part to solve, when you have to create now a security boundary, but still share and trust that whatever you sent that way is okay to have sent that way, and you never send something you never want to send. So mission partner environments in this Golden Dome has to be data aware, so that you can finally define what it is that you are allowing to move between those discrete enclaves, so that you can be effective partners in warfare. What does that mean when it graduates Golden Dome into the commercial world, right? This is the world's biggest LAN. Right.
If it's all right, I'd like to touch on the speed part again. I know you've mentioned it a couple of times, the speed of relevance. Obviously, we have this massive amount of data at the edge, the booming data, and then it's important to move it and for it to get to the right place and go to the right person. How are we making sure it arrives quickly, and especially within the Golden Dome architecture? Is it using AI now and the ML? I know you briefly mentioned them. How are we making sure it goes quickly?
It's a few parts. It's partnerships, working with great partners out there like Anduril and Palantir and folks like this, where they have looked at their data structure and understood that the data is king to them, and understanding how to have a solid data structure and a data model that you can operate off of is immensely valuable when it comes to multi-domain operations and the ability to move that information securely between those enclaves. So to me, it's in that aspect is these tight partnerships, but it's also the moving of a line for the industry. So traditionally we looked at firewalls and we looked at DLP and application-based security systems. Yeah. They didn't provide you the true value of looking at all the other layers in between and saying, are those things that I should be aware of? We typically worried about those when they got into our data centers, when they got into our on-prem systems, right, servers. We don't believe that that's a good idea. We did it for a security reason, but the added benefit of that is that if I put this firewall, right, this guard in place of where a firewall would have lived on a satellite, in a communications node, right, in the back of a vehicle, I've secured that threat landscape, but I've also given an added benefit of being able to move data between distinct domains, security domains.
But have you slowed it down at all?
It would have been slowed down by the security appliance regardless.
Okay.
What we've done is not slowed us down as much as them, and provides you a level of security on the opposite side of that, and the ability to move data efficiently. So what I do add is a bump in the wire, but I don't add significant delay to the packet moving through, but I do give you the benefit of bifurcating data, keeping it on a plane and copying what I need to move off to the other side, or moving it wholesale to the other side before it ever traverses back out of the satellite network into a coalition space or a rail space, a secret rail space, right? So I could now decide on a satellite that I can send it just my coalition broadcast, or all my Five Eyes broadcast, or just my US people's broadcast. It was just going on the US one before, right? But now I've in flight parried off information to be moved into a secure broadcast, so that all those systems that operate off of non-traditional communications brokering protocols like TCP/IP, where they're talking back and forth, right? The systems we're describing, they're just listening for commands, right? The acknowledgement of a command is the firing of a missile, right?
Yeah.
They don't send back like, oh yeah, I'm going to send it. You send it. I sent it. We're sending. Like, that doesn't happen in missiles. It's like send the missile, bang, and missile fires, right? So in that is the ability to now move at a better speed. So before, that same information would never get bifurcated. It would get sent back to a place and get sent back via radio protocol, or via another terrestrial land site, or maybe back through the same satellite network. But it had to go back. So 44,000 kilometers in space is geosynchronous. The speed of light is a thing, right? It does not travel faster in space than it does on Earth. So this thing hits that satellite and comes back, and that's already the delay. You haven't even done anything like a human. You've never put it through another machine to figure out what it was. Nothing's actually happening. You've only got 2 seconds of delay, right? And somebody's life's at risk. So the chain has to be closer to Earth because physics, right? And when it does end up leaving Earth or going through a terrestrial cable, the fastest route that it can take, it takes that route, right? And space is going to be the fastest route. If I'm in Germany, I'm going to use German telco, French telco, Spanish telco, then a fiber optic cable that hopefully the Russians didn't cut, right? to then the data center, right? That's a death loop. That loop has to be in a tighter circle at the edge, and Golden Dome is it's too big of a 2-word statement, right? Of a 2-word thing of Golden Dome to describe it, but it is a very dense layer of cakes where you're building the infrastructure for the 21st century modern communications transport, right? That's exactly what this is. And Golden Dome is just a way to fund it, put money towards it, in a wrapper of an idea of what it's going to be. But really, we're already built the shooter and sensor platforms terrestrial, right, in some space, right? We're going to flush those out completely just to make sure that we have all the sensors that are required to be there now, right? And then at the same exact time, it's to build out this massive, resilient, satellite constellation and ground terminals and all the reinforcing data centers and AI in space. Like all these are coming. Every single SpaceX satellite is a sensor and a satellite constellation. It isn't just a satellite, right, that reflects the comm signals. It is a multispectral sensor. It is a communications node. It is now going to be an AI machine that can take the information that's passing through it and take the information that it's seeing, and it can do things with it. You also don't want that to be within the same computing space, right? You want a level of system and separation between traversing information and information that happens to be within that space.
And that lovely little segue onto my next question, which is, we've discussed the speed, obviously, but just knowing all this data is moving around doesn't necessarily mean you can trust it, correct? How are we ensuring that we can trust the data that's now going through these, I'm going to call them space age communications networks?
This is where the zero trust principles play to us and the area that we live in as a technology, right, sphere, is that we were forgotten in these important transactions of encryption and verification and implied trust versus absolute trust, and being able to revoke those trusts weren't something that we typically spent a lot of time in because it had happened before, it happened after, and I was just the inspection piece in the middle. What we see now is as a need for those two spaces to carry further into the systems than they typically did, where they would hit a network and the network would basically validate you and your authority. And after that, I just granted you everything else again back to your individual identity that you had. In this scenario, right, we're talking about that data density at the edge. Why do we need to be able to move that information within those spaces, right? And that is where multi-domain operations, the complexity that we've moved out. So imagine that until very recently, until probably the last 5 years, I can take the level of compute to replicate a cloud environment beyond the cloud, beyond a Google-owned data center, and all the virtualization, the hyperscaling, everything that a cloud capability gives you without the building size didn't exist in an ability to put anywhere else. That changed. Now I can take that exact same capability and I can put it anywhere. And in this new environment that we walked into, where I can do a lot more with the sensors, the AI, and compute now in a place where I could never do it before. And that has given me the ability to run massive drone swarms, right? To ingest thousands of petabytes of video data, to have radars set out 100 miles apart from each other and not have an individual anywhere near those things, and be able to move all that sensor data, 100 gigabits of data a second, right, that it's generating on a radar, and move that information through a network and into a space. that's stovepiped, right? Now,
Yeah.
that's a lot of data that I've created, a lot of like validation of data that I've created that's just stuck in a single plane. It's not useful for the French. It's not useful for the German. It's not useful for the Brits. It's not even useful for the plane that's above you that has to that can shoot, because that's on a whole different network. It's on top secret, right? And this plane, all this information for this individual is on secret. And now I'll never get the sequencing to happen in today's stovepiped environments. This is where we talk about the time to live and moving the data at the speed of relevance, right? That individual is the relevant one, and everything that puts that individual or those assets in jeopardy is this motion and data need. So when we talk about satellites or on your person or on your body, or having these data routing, data aware security appliances that you're running, this is what you're getting out of that. Is you're getting the ability to not just get a pipe and figure out what trash you have through that pipe, but figure out that there is a bunch of good stuff and a bunch of potential risk there. Let me get rid of the risk that this brings along, and give you better data clarity and ability to make that data useful to you when it really counts. And that's it. That's where this this moving of data across these multi-domain boundaries, building these mission partner environments, all this is infrastructure that's going to ride on Golden Dome, right? Like the action items are in there, the pieces that make, affect the environment that they're in are in there, but making them, orchestrating them, making them work at scale, making the information move, and then moving it within those tight loops, within the areas where people and equipment are at risk. That's where you keep the information at the tightest loop. If I want to see a map with a bunch of little dots on it, that can be 10 seconds late, right?
Yeah.
That can be 2 seconds late. A general seeing a screen to just show them a picture of the globe and a little thing moving across it is not the thing that's important, right? The thing that's important is that radar, that person, and the person that pushes the button, right? And that they're shooting the right thing. And if there's no human, that the machine is picking the right weapon for the right system on the right classification to engage it, right? So it's like these interesting data loops that we're working on building the architecture to make as quickly, as efficient as possible, so that, yes, you can inform the rear, you can inform Northcom, you can inform, Indo-PACOM, but North Korea, yes, the North Korean missile has been shot out of the sky at this point, right? Like the guy in South Korea fired.
Yeah. So it's all about moving the data across domains between allies and getting to the right person at the right time at speed, essentially, and hopefully in a way that we can trust it. I'm still somewhat confused between like how that all fits in with Golden Dome. Is that not already happening? Is Golden Dome just the name that is towards all this?
You're right. It does happen today, but it happens through multiple different asynchronous methods. So when you talk about there's a good movie on Netflix. I'll have to remember the name, but it deals with what happens in the minutes that a nuclear weapon is launched.
I've seen it. I also can't remember the name of it.
I've worked in all those places, by the way. Like I've sat in those places, which is interesting, right? So you get to watch this sequence. So imagine that in that sequence, there is 4 different locations, radars, that have to track the system inbound, right? And then those are all terrestrial, and then there's a couple in space that can do their own bit. All of those are on different multi-domain security enclaves, owned by different government agencies with different authorities. So imagine that NASA's one, the National Reconnaissance Office is another, the Geospatial Agency is another, and Stratcom is another, and Northcom is another, and they all, and South Korea, they have their own, in Japan, in Hawaii. So all of those, every single one of those places has an effector. They have a missile that can reach a certain level of altitude, right, in range, to hit a missile within a particular trajectory of flight. That coordination today is done with an informational, an action, and an awareness, like 3 separate piles of people who are all within getting information from all the sensors, that have relatively different roles and timing that they have to be concerned with acting and deciding.
And possibly on different domains.
and 100% on different domains. Like and they are 100% on different domains. Okay.
Okay.
So that's the wild part is now today it's humans on phones, right? And you're looking at screens, just like the movie. That is the chaos that happens in when you don't obfuscate complexity in multi-domain environments, right? Golden Dome is a desire to remove the friction in a multi-domain environment to the best that they can, while still keeping, right, the next thing will be the separation of the pipes inside to make sure multi-domain stays secure. But it's a desire to create a new transport layer that makes it easier to condense the data where it's needed, right? So that I can send it I can generate it in South Korea, and send it to Japan, and be able to send it at the relevant time to them, and be okay with the delay going to the Pentagon, right? Like, the chairman of the Joint Chiefs of Staff is not going to be the person saying like, oh my gosh, let's fire the missile, right? That's actually a phone call, because it's faster for me to tell you to fire than it is for me to today deal with all the ping ponging through all the networks to get my button press here to get it all the way over there. So in that is like that button not being able to be pressed by me from here to there is basically one of the big pieces of why there's so much complexity. And now you got to throw in Canada, because they have a part in this, right? As part of this North American alliance, as part of NATO. So you throw in all that complexity, and you add delay, you add chances for information not to be passed. So all that is this modernization of the entire architecture, so that we can get rid of the phones, so that we can get rid of the 7 places where this actually has to happen, right? And if they do have to exist, that they have the information they need at the most relevant speed for them, versus at whatever speed of the owner that has to then share that information back out. So like NRO has to send it back to NRO to send it back out. NGA does the same thing. And it's like all that information was generated within regionally the same exact place, right? Those sensors can't live in 2 places at once. So that information could have flowed in many different directions across those multiple domains, without having to reach the backhaul point of the owner where they deal with their data density issues before that data can come back out, right? So this is where this would be a transformational change, if data awareness on the wire as it's generated, to move it within those multi-domain enclaves, so that you're not having to reach all the way back to the owner's data density hub to then hub and spoke back out to you, right? This is what we have to get rid of, or Golden Dome is just as useless as 2 phones and a computer.
So do you think, moving forward and looking at how Golden Dome evolves, do you think the sensors, the interceptors, or the data layer that connects everything becomes most important? Which of the 3 are we looking at? I feel like I know what the answer is going to be, but
the data layer in the robust space transport layer, like that is, if you can create a truly robust space transport layer.
Can you explain what a space transport layer is slightly?
So today, if any satellite network, you basically have 3, 4, if they're the low Earth orbits, hundreds of them that are rotating around the Earth.
Yeah.
Today, I would go to a satellite, I would go back to a ground terminal, and I would use to whatever space ground transport they use. And from there, I would go via a terrestrial cable, or over to the next satellite station, then back up to another satellite and back down. So you would always do like a W or a V, right? The issue we have is in that W or in that V today is, well, one, it's all that delay of having to go back up and down, back up and down. So if you ping pong once, one V is four times talking to each other to get to pass information. Right. If you've got an M, you're talking about 8 times that you've got to go back and forth through this tree to go to do your stuff, right? So it's this, every bit of that is this delay that's added because there isn't enough space transport to move it efficiently, satellite to satellite to satellite, to the actual destination, not to another ground terminal, but to the place that you wanted to deliver it to. So if I wanted to send it to you, I would never touch the ground. I would talk to you. It would go to a SpaceX satellite. It would go via lasers, and then directly down to your phone.
Brilliant.
Because that's what we're giving. That's the biggest land on the planet. This is the beauty of what this transport gives us. And if I can go point to point to you, then I can broadcast to anybody I want to broadcast to on that same exact network, as long as you're always listening. So this is where the space transport gives us this incredible advantage of being able to be more discreet with how we move data versus how we move networks. And because it's a global network, it gives me a even better ability to be more prescriptive of how I move and how quickly I can do that within that secure enclave, which is what we're going to get with Golden Dome when you get a SpaceX or a AWS, building these government architectures out in space. That benefit
on the moon.
Yeah, and then on the moon, right? People think it's silly, but the economy of space has become a real thing because they've made it so cheap to put things in space. Nobody wants to put a $100 million satellite in space, right, and pay another $100 million to get it there, right? They just want to pay the $100 million to get the thing up there so they can start charging people for what the sensor can do. And you can see this now as the commercialization of space. There is a vast number of sensor companies that are putting sensors in space and selling the information out of those sensors. That is now coming back to a hub and spoke, architecture that this is something that Golden Dome will end up solving for them as well, right? Where this now can be a more representative LAN than it is a worldwide communications web.
Is Golden Dome going to leverage a lot of private organizations or commercial organizations within space, like Starlink-esque, or are they looking at setting up their own infrastructure up there?
They are planning. The government is going to buy their own versions of SpaceX satellite constellations.
Brilliant. No more relying on Starlink.
It's one of the same, but in the PEZ dispensers, when they're shooting out 30, 40 PEZ dispensers, and they can launch 4 starships a day, you can put up a lot of birds, and that's just when they're not using the entire starship to launch satellites in space. That's just when they're launching 2 things in space and they want to have extra. They could make an entire PEZ dispenser starship that just pops out new ones every location as it flies over to its orbit. It's a different time. It's gone from hundreds of millions to tens of millions to launch.
Yeah, it's incredible. I think that's about all the time we have. That's around the half-hour mark. Chris, thanks so much for coming on. I thought that was fascinating. I really like the idea of Golden Dome being just a data connectivity portfolio rather than a full interceptors thing. But I really enjoyed the conversation. Thanks so much for coming on.
My pleasure.
We will be back next month with another Fox Forum. If you have any questions for us, there will be a place around where you're viewing this video to reach out, and I'm sure Chris or myself will be able to answer questions you have. And that's about it. Thank you very much for coming on, Chris, and thanks very much for listening, everyone.